Okay, welcome to the next part of uh, Chapter 12, Quantitative Techniques for Decision Making. The next topic is linear programming. It is a mathematical technique that permits the determination of the best or optimum use of available resources, namely money, personnel, materials, facilities, and time. So in short, linear programming is used for determining the appropriate combinations of our available scarce resources, because sometimes our resources are our limitations, so we have to utilize it at its maximum. Otherwise, magkakaroon siya ng mga slack or uh, extra time na hindi nagamit or unused uh, capacity. So we have to set or determine how the numbers of units or maybe hours that we need to spend so that we can maximize its use. Okay, paano siya gamitin? Here are the steps. Define first the decision variable. What do you want it to do? Whether to maximize it or to minimize the use of it. Dalawa lang naman, maximize or minimize. And then express the objective function and constraint in terms of these decision variables. Say you wanted to maximize profit, then you have to express a function, an objective function, on how to be able to get the maximum profit. If your objective is to minimize the cost, you need to prepare a objective function on how to minimize the cost. And then we have three methods of, ayun yung nawala kanina, algebraic pala. Three methods of linear programming: graphic method, algebraic method, and simplex method. Okay, we'll go for graphic method first. In graphic method, you need to have or to use a paper, a special paper, yung ginagamit sa, I forgot anong tawag doon, sa math, yung maraming square, graphing paper. Yes, graphing paper. Otherwise, you need to create something na equal ang sides so that you will be able to plot the correct lines. Pag hindi po kasi equal yung mga squares, there's a possibility na hindi mo tamaan yung tamang lines. So you may use graphing paper whenever you apply graphic method in linear programming. Okay, let's apply this one. So for our illustration, a firm produces two products, A and B. A requires 2 hours of grinding and 4 hours of polishing. Product B requires 5 hours of grinding and 2 hours of polishing. The manufacturer has 3 grinders and 2 polishers. Therefore, in a 40-hour work week, there are 120 hours of grinding and 80 hours of polishing. How did we get yung 120? Since 3 yung grinders niya, 40 hours ang isa, so meron siyang available hours of 120 hours. Yun namang polishers niya, since dalawa, at 40 hours ang isang linggo, kaya 80 hours ang available sa polishers niya. There's already market for both product, and the contribution margin per unit of product A and product B are 3 pesos and 4 pesos respectively. To maximize the total contribution margin, the management must decide on the allocation of the available production capacity to products A and B and the numbers of units of each product to be produced. Okay, since product A requires 2 hours of grinding and 4 hours of polishing, while product B requires 5 hours of grinding and 2 hours of polishing, we need to determine how many units of A and B that we need to produce, and that unit will be within the capacity of the the grinders and the polishers, and that is 120 and 80. Imposible po na humigit siya dun sa capacity ng 120 and 80. So we are trying to find out the numbers of units within that limit of 120 and 80 hours for grinders and polishers. And also, aside from that, we need to also determine the numbers of units that will give us the maximum profit or the maximum contribution margin. Okay? Provided we were able to follow yung limit niya na 120 and 80. So maximize the capacity and maximum profit also. So for graphic method, again, we will be using a graphing paper. So these are the first step. You need to set the decision variables. That is to assign a variable for the numbers of units. So let A be the numbers of units of product A and B the numbers of units of product B. So therefore, if our objective is to increase the profit, the formula for the total profit or total CM is 3A plus 4B, which should be the total maximum CM. Our constraint or our limitations are for the grinding, that's 2A plus 5 hours of B should be less than or equal to 120. It is less than because that's our limitation. Pag beyond 120, hindi na natin magagamit yung machine kasi hanggang 120 lang yung grinding. So the same goes with polishing. 4A plus 2B should be equal or less than 80 hours because we are trying to find out what is the amount or the number of units within that limit. And then A and B should be greater than or equal to 0. Meaning, pwede po tayong mag-produce ng puro A lang, walang B, or puro B lang, walang A, or a combinations of any amount aside from 0, A and B. Imposible po ang negative. Okay, walang negative 1A, walang negative 1B. Na negative produce, wala pong ganon. So it should be greater than or equal to 0. Okay, so I have here a simulated graphing paper. I tried to make it as equal as possible. Hindi po talaga siya equal, so pagtiyagaan na lang po natin. Okay, the y-axis is our A product or the product A. X-axis will be our product B. And then we assign values for each line that is between 10 to 60, 10, 20, 30, or increment of 10. And now we have to draw a line for our constraint or limitations. For the grinding, ang ating function is 2A plus 5B is less than or equal to 120. So if this axis or y-axis is A and x-axis is B, to find out the point for the B, we will assume that A is 0. So if A is 0, so 2 times 0 is 0, plus 5 times B is equals to 120. So you need to divide 120 by 5 to get 24. Okay, ulit. How did we get 24? If A is 0, and then 2 times 0 is 0. So you may eliminate that, yung 2A. So therefore, ang matitira na lang is 5B is equals to 120. To get the value of B, you divide both sides by 5. That's 120 divided by 5, and 5B divided by 5. Ang matitira na lang is yung B is equals to 24. Okay? So, ganun lang. Papalitan mo lang yung isang variable muna ng 0 because ito yung hinahanap natin, yung x-axis na ito. Saan yung starting point ng B sa floor natin. So, therefore, A is 0. And then you find for the value of B. And based on that, 24 yung value ng B. So, somewhere here. Okay? Yun yung point na yun. And then to get the value of A, we do the same. We assign 0 to B, and then we divide both sides by 2. We will get 60. So the value of A is 60. B is 0, A is 60. Okay, yun yung point na yun. And then you draw a line between connecting A axis and B axis. So this is our grinding limitation. And then for the polishing, 4A plus 2B is equals to 80. Assuming A is 0, the value of B is 40. So ito yung 40. And then for the value of A, assuming B is 0, A is 20. Divide both sides by 2, A is 20. Divide both sides by 4, A is 20. So connect the dots again. Yun. So at this point, we now have a possible region or feasible region for our combinations of products A and B. And that is this point, 0B and 20A, 0A and 24B, and 10A and 20B, or 0A and 0B. Okay? So that will compose of our feasible region. Ito yon. So beyond that, hindi na yun feasible because it will not fall within the limits. Ito, yung sa polishing, anything beyond this one is not feasible for polishing. Although within the limit of grinding, hindi naman ubra sa polishing. Anything beyond this line also is against the limitations of grinding. So in this case, pwede sa grinding, hindi pwede sa grinding, yet pwede sa polishing. Itong side na ito, hindi pwede sa polishing, pero pwede sa grinding. Okay? So hindi yan feasible, hindi rin to feasible. The only feasible region is within this limit. And then we get the points at ito yon. A is 0, B is 0, A is 20, B is 0, A is 0, B 24, A 10, B 10. Okay, after determining the points, we can now solve for our maximum contribution margin. You simply apply the points. So if you choose A0, B0, the contribution margin is 0. A20, B0, we will get 60 pesos contribution margin. If we will not produce A and we will produce B only, we will get 96 contribution margin. But if we produce 10A and 20B, we will get a contribution margin of 110. So therefore, the appropriate combination of producing product A and B is 10A and 20B to earn a contribution margin of 110. Okay, so that is how we use graphical method in solving linear programming. Next is algebraic method. So in algebraic method, we simply combine the two terms and find the value of the variables. So dun sa graph, grinding and polishing, we simply combine them. This one is the polishing limitation. 4A plus 2B is equals to 80. Less than or equals to 80. And then 2A plus 5B is equals to 120. And we need to combine this one to get the value of B. However, hindi po magkaparehas yung amount of A natin. Pag hindi siya parehas, we will not be able to cancel it. Kaya we need to find a value that will make this similar to the first term. And that is 2. You simply divide 4 by 2, you will get 2. So that when we deduct the second term from the first term, magka-cancel out siya. Okay? So 4 divided by 2 is 2. And then multiply all the variables or all the component in that term with 2. So 2 times 2 is 4. 2 times 5 is 10. Hindi ko siya napalitan. Sorry, let me change this one. Okay. So 2 times 120 is 240. Ako, naka-mic ba ako kanina? Okay. So hindi ko na naman na-highlight. And then we can now deduct the second term from the first term kasi parehas na siya. So magka-cancel na yan. And then 2 minus 10 equals 8. If you wanted to use negative, okay lang naman. Negative 8b is okay. 80 minus 240 is negative 160. And then you divide both sides by negative 8. So negative over negative is positive. Negative 160 over negative 8 is 20. So therefore, B is 20. We can now solve for the value of A by replacing the variable B with 20 using any term. So let us use yung first term, that is 4A plus 2 times 20 is equals to 80. So combining similar terms, 40 and 80, wala siyang variables. So combine mo yan. But when you transpose it to the other side, magbabago siya ng sign, magiging negative. So 4A is equals to 80 minus 40. And then you divide both side by 4 para mag-cancel yung 4, may iwan yung A. So 80 minus 40 is 40. Divide by 4 is 10. So B is 20, A is 10. So the same siya dun sa algebraic method natin na A is 10, B is 20. Sorry, algebraic graphic method. Okay? It seems like it's more easy to use algebraic method. But actually, meron pang isa, which is the same amount of contribution margin, which is the simplex method. So 3A plus 4B, or 3 times 10 plus 4 times 20 is 110. Let's go now to the simplex method. Using the simplex method, we also have to set up the objective function and the constraints. That is, to find out the maximum CM by multiplying 3 times A and adding it with 4 times B. Our constraints are the same. Grinding is equals to 2A plus 5B should be less than or equal to 120. And then polishing is 4A plus 2B should be less than or equal to 80. And A and B should be greater than or equal to 0. Now, the steps in making a simplex method or using the simplex method and setting up a tableau for the computation, we need to first set or assign a slack variable. And what is a slack variable? This represents the numbers of units that we will be looking for in cases we will not produce A and we will not produce B. So, ilan yung oras na available sa kanya? And that is the slack variables. Okay? So, we will assign one slack time or one slack variable for grinding, and we will assign also one slack variable for the polishing. So, hindi natin nalagyan ng value ng 1 kasi pag wala yung value, automatic 1 yun. Okay? So, for the grinding department or process, this is now the new term, 2A plus 5A plus the slack variable, because we wanted to find out ilan ito, and this will be replaced later kung ilan yan. For the meantime, we will assign one variable, assuming hindi tayo nakagawa ng A and B. And then, 0 yung variable ng polishing. Okay? 0 yung amount ng variable ng polishing sa grinding. And then sa polishing naman, we will assign one slack variable for S2, or this is the slack variable for polishing. And of course, 0 sa grinding. Isasama natin sila because sa isang computation, because each one is connected to the other. Kaya kung puro grinding lang, we have 0 polishing. Kung puro polishing naman, 0 grinding. Okay? Now, the revised function is 3A plus 4B plus 0 grinding and 0 polishing. Okay? You need to pay closer attention to this because this one is a little bit complicated. So for the tableau, you first set up the headings. Yung first column will be your contribution margin per unit. You need contribution margin per unit. And then the second column is the mixture of the numbers of units that you are trying to solve. Ilang A, ilang B, ilang S1, ilang S2. Okay? So this one is a mixture. And then yung third to seventh column, third to the seventh column, yung upper portion is our objective row or our contribution margin. Meaning, dun sa kaninang objective natin, ito, 3A plus 4B plus 0S plus 0S. Ito yun. 3, 4, and 0 and 0. We assign 0 for the quantity for the meantime because we don't have yet the quantity yet. Okay? And then yung second row will be the variable row. So 3A, 4B, and 0S1, 0S2. A represents the quantity of product A, quantity of product B, quantity of slack variable in the grinding, quantity of the slack variable in the polishing. Next is, let me just mention first the parts of the tableau. The third up to fifth row are the problem rows. Dito tayo magsasagot. And this is where we'll do our computation, our arrangement. The index row, or yung the last row, will also be our benchmark, kaya sa tinawag na index, whether we were able to reach the maximum combinations of quantity already. Dito tayo titingin sa baba. If sa index row ay wala ng positive value, puro 0 or negative na lang, then we were able to arrive at the maximum combinations of quantity. Okay, so again, ulitin ko yung rule sa index row. Dapat walang positive value, either 0 or negative lang. Hanggat merong positive value, aside from 0, ibig sabihin lang nun, hindi pa natin nare-reach yung maximum combination or the appropriate combinations of quantity to arrive at the maximum contribution margin. Okay, let's start. So, una, let's write down first yung constraint natin for the for the grinding department. We have 2A and 5B and 1 S1 or 1 slack variable for the grinding and 0 for the polishing. Saan to nang galing? Ito po yun. 2A plus 5B, 1 S1, and 0 S2 for the grinding. Okay? We will assign, and quantity is equals to 120. We will assign S1 for the slack variable for the grinding for this one, and we don't know yet kung ilan yun. Kaya slack variable muna ang gagamitin natin. And the contribution margin for S1 is 0. Okay, 0S. Kaya 0S. The contribution margin. And then we also write the second constraint, which is the polishing department. That's 4A, 2B, 0S1, and 1S2 equals 80. And then we assign S2, the slack variable for polishing, with 0 contribution margin. Okay? And then you multiply the contribution margin on the first column to the quantity on the third column. You multiply. Okay, so 0 times 120, and then the other one is 0 times 180. And then you add the 2, that is 0 also. Okay, we call it ZJ, or the total income. That is the sum of 0 times 20 and 0 times 80 equals 0. And then you deduct the first column na 0 sa taas, 0. Oh, sorry, let's compute for the remaining column first. So 0 times 2 and 0 times 4 is 0. So therefore, everything is 0. Okay? And then you will deduct 0, the first row, to the resulting total income. So 0 minus 0 equals dun sa index row, 0. Ulit, so 0 minus 0 equals dito sa index row. Objective row minus the total income equals 0. So you repeat the operation, 3 minus 0 equals 3. 4 minus 0 equals 4. So 0 minus 0 equals 0. 0 minus 0 is 0. Okay. So now that we were able to complete our first tableau, you have to check it if it satisfies the constraint and the objective. And that is whether it is within our limit. So in terms of quantity, 120, nasa within pa siya, 120 din. Time is 1 is 120. Kasi may 1 yan dito eh. 180 is 80. Nasa within pa rin ng polishing department, within pa rin ng grinding department. And then, for the contribution margin natin, puro 0, within pa din, but that is not the maximum contributions that we need. Hindi natin gusto yung 0. We wanted positive contribution margin. Okay, second is, it is a rule in Simplex Method that the optimum solution for maximization problem has not been reached if the index row still carries positive values at the completion of the iteration. So check your index row. Meron bang positive amount? Yes. 3 and 4. Okay? So hindi pa natin na-reach yung maximum contribution margin natin because we still have positive values under our index row. So the next step is to look for the row that we need to replace. Kailangan nating palitan yung quantity na to, either yung 120 or yung 80, para matanggal natin yung mga positive values dito sa index row natin. So we have two rows here available, S1 and S2. We need to know which one are we going to replace, or ang tawag nila doon ay outgoing row. So for us to determine, we have to get the lowest positive ratio. And what is that ratio? You simply divide the quantity by the amount in the highest positive value in the index row, and that is 4. Okay? So within the index row, ang pinakamataas po ay yung 4. And then after identifying which one is the highest, you divide the value corresponding to that row, which is 5, 120 divided by 5, and 80 divided by 2. So after dividing, ang may pinakamababang ratio is yung S1, which is 120 divided by 5, which is 24. Therefore, we need to replace S1. This is the outgoing row. Now, alin ang ipapalit natin? The highest value in the index row, and that is B. So we will replace S1 by B. Okay? Ito yun, no? So, 4 is the highest value, positive value in the index row. We get the ratio of each amount doon sa each row, and we were able to identify S1 as the lowest positive ratio, that is 120 divided by 5. Kaya ito yung pagpapalitin natin. So, let's construct again our tableau, the second tableau. Okay na tayo sa mga headings, the same. At this point, from S1, gagawin nating B. Replace it with B. Okay? And then, the B row, to compute for the quantity that you will input on the B row, you simply follow the operation of dividing the value on that particular column with 5 as the intersecting value between the highest in the row and in the index row and the outgoing row, which is 5. So 120 divided by 5 is 24. Okay, ulit, 120 divided by 5 is 24. That's the intersecting cell between the highest in the index row and the lowest lowest ratio, positive ratio, which is S1, and that is 5. Okay, so 120 divided by 5 is 24. So how about sa column ng A? We simply divide 2 divided by 5. We simply follow the operation. So 2 divided by 5 is 0.4. 5 divided by 5 is 1. 1 divided by 5 is 0.2. And then 0 divided by 5 is 0. Then you may now input the value on the B row. And then copy the contribution margin of B column. And that is 4 dito. Okay? Ulit. How are we going to get the value of B under the quantity column? You simply divide 120 by the intersecting value, which is 5. 120 divided by 5 is 24. And then you do the same for the next columns. And then you copy and paste the contribution margin of B, which is 4. So you put it also under the contribution margin column 4. Okay. Next is, we will not replace yet S2, but we need to change the value on S2 row. That is 80, original value is 80, minus 2, the intersecting variable or the intersecting value, and then multiply it with the value above that S2 row, which is 24. So ulit, 80 minus 2 times 24. 80 minus 2 times 24 equals 32. So you follow the same procedure in the following column. So for column A, That's 4 minus 2. Wala yung arrow ko. 4 minus 2 times 0.4. Okay? 4 minus 2 times 0.4. So for column, that is 3.2. And then 2 minus 2 times 1 is 0. Okay? 2 minus 2 is 0 times 1 is 0. And then 0 minus 2 times 0.2. And that is negative 0.4. 1 minus 2 times 0 is 1. Okay, let me explain this one. You multiply first before you deduct. That's 2 times 0 is 0. So 1 minus 0 is 1. Okay? Ulit, bakit naging 1 yon? That's 2 times 0 equals 0. So 1 minus 0 is 1. So ganun din dito sa other computations natin. And then copy-paste the contribution margin per unit for S2, which is also 0. And then let's compute for the total income, which is ZJ, by multiplying again the contribution margin with the quantity for both items and then add. So 4 times 24 plus 0 times 32, yun yung lalagay natin sa ilalim niya, 96. Okay, let me flash it again. 0 times 24 plus 0 times 32 equals 96. And then you do the same for the rest of the columns. 4 times 0.4 and 0 times 3.2 equals 0. This is 1.6. 4 times 1 is 4. 0 times 0 is 0, so equals 4. 4 times 0.2 plus 0, that's 0.8. 4 times 0 and 0 times 1 is 0. Okay, let's now solve for the index row. You simply deduct yung nasa taas with the value of your total income, and that is negative 96. You do the same sa other columns. That's 3. 3 minus 1.6 equals 1.4. 4 minus 4 is 0. 0 minus 0.8 is negative 0.8. 0 minus 0 is 0. And then you apply again our rule whether there is still a positive value in the index row. If there is still, if there is, then we were not be able to able to compute yet the maximum combinations of units to get the maximum contribution margin. Hindi pa yan yung proper combination, 24 and 32. Okay, so again, how are we going to know which row will be changed or eliminate or replaced? We simply get the positive ratio. 24 over the highest positive value in the index row, which is 1.4. Ang rule kasi natin dito, 0 or negative. Meron pang positive 1.4. So this one is the highest positive number. So dito natin i-divide yung quantity ng nasa row natin. So 24 divided by 0.4 and bakit 50 yun? Mali lang po yun ha. 24 divided by 0.4 and then 32 divided by 3.2 is equals to 10. Okay, so comparing 60 and 10, choose the lowest positive ratio, we will choose S2. So we will replace S2. And ang ipang i-replace natin, the highest value in the index row, which is A. Okay? So ito na yon. Highest index row value is 1.4. Lowest positive ratio is S2. 32 divided by 3.2 is 10. Comparing 24 divided by 0.4 is 60. So ito yon. I-replace natin siya ng A. So, let's put A on this. This is our third tableau na. And then, divide 32 divided by 3.2 is 10. For A, 3.2 divide by 3.2 also, that is 1. 0 divide by 3.2 is 0. Negative 0.4, negative 0.4 divided by 3.2 is negative 125. And then 1 divided by 3.2, that's 0.3125. And then copy paste the contribution margin to the first column. That is 3. Okay, and then let's now solve for the value of B. We will not be replacing it. Yan pa rin siya, B pa din. But yung quantity niya and the rest of the columns will be changed. So, kung paano natin ginawa dun sa unang process natin, we will do the same here. We simply deduct yung original amount dun sa intersecting value between A and B, which is 0.4. And then multiply it with what is under it. Kanina above, ngayon naman under it. So 10. 24 minus 0.4 equals times 10. Pero ganun pa din po, you multiply it first and then you deduct. Okay, so 24 minus 4 is 20. Yeah, 20. You do the same sa other columns. 0.4 minus 0.4 times 0.4 times 0.4 times 1, and that is 0. And then 1 minus 0.4 times 0 is 1. Parang nangyari yon, 0.4 muna times 0 equals 0. And then 1 minus 0 equals 1. Okay? 0.2 minus, that's 0.4 times 0.0125, okay, equals 0.25. And then negative 0.125 dun sa last column. S2. Then copy paste the contribution margin of B. That is 4. Okay. Now we can compute now the total income or total contribution margin again using the same procedure, multiply and then add. 4 times 20 and 3 times 10 equals 110. So you do the same for the rest of the column. 3, 4, bilis natin. So 4 times 0 is 0. 3 times 1 is 3. So add 3. 4 times 1 is 4. 3 times 0 is 0. 4 plus 0 is 4. 4 times 0.25 and 3 times negative 125, you add 0.625. And then the last is 0.4375. Okay, we can now compute for the index row and check whether there is still a positive value in the index row by simply deducting the column heading by the amount in the total income. So 0 minus 110 is negative 110. 3 minus 3 is 0. 4 minus 4 is 0. 0 minus 0.625 is negative 0.625. And 0 minus 4.4375 is negative 0.4375. So at this point, wala na pong positive value in the index row. Either 0 or negative na lang siya. So therefore, we were able to reach the maximum combination of our product mix and the maximum amount of contribution margin, which is 110. Okay, so similar to what we were able to compute in the algebraic method and the graphic method, A is 10, B is 20, we will have the same contribution margin of 110. Okay, let's now proceed to the shadow price. This is the opportunity cost or the monetary value of the contribution margin that would be lost by not adding an additional hour of capacity. Let's go back to our previous example on the graphic method. Okay, hold on. Okay, for this one, our limitation is 120 hours for grinding and 80 hours for polishing. Now, the shadow price is a concept that if we will add 1 hour for grinding or 1 hour for polishing, how much will be the added contribution margin for the added hour? Okay? Magkano daw yung dagdag sa contribution margin natin if we will add 1 more hour for the grinding and the polishing? Or the polishing, not and, or the polishing. So in our solution in the graphic method, our feasible regions are A0, B0, A20, B0, A0, B24, A10, and B20. If we will add 1 more hour for the grinding, this may shift upward kasi dagdag isa, kaya magkakaroon ng changes on the points, on the intersecting points. So, let's move to that example. Okay, hold on lang po. Yeah, ito po. So again, we add 1 hour for the grinding. Instead of 120, this time we will change it to 121. And if we do this line will shift upward, kaya medyo lalayo siya. Ayun po. Hindi na siya 10, hindi na rin 20. This will become 9.875 and 20.25. Okay, you can compute it using the algebraic method. Okay. After doing that, we will compute now the former CM or the optimum CM with the new CM. And we will now arrive at the shadow price of 0.625. So for every hour added in the grinding department, we will add 0.625 in the contribution margin, which we were actually computed using the simplex method. Remember that the shadow price for grinding is 0.625. Going back to our last tableau in the simplex method, we can find 0.625 under the column of the slack variable for the grinding department. So if we will compute for the shadow price of the polishing department, we will arrive at 0.4375 additional CM for every hour added in the polishing department under the slack 2 for the polishing department. Okay, so ito na yung shadow price. Ayun pala, sorry. Okay, next is program evaluation and review technique. Under PERT, this tool is used for normally for project based problem that requires computation of time and possibility of the minimum cost of producing a project or finishing a project, the least time at the least cost. Okay, now for PERT analysis, we need to first understand that this kind of technique uses, again, symbols that represents a variable. And the placement of each symbol has a significance on the analysis, meaning the first circle is a predecessor event, meaning we cannot go to the successor event unless we finish the predecessor's event first. Okay, and then the arrow in between the circles are the run system test or the one with a period or time frame. So for this one, it's 4 weeks activity. And then the circle after the arrow or the line is what we call a successor event. And therefore, the successor event will not occur unless the predecessor event are finished within the time frame specified in the lines or in the arrow. So this is a typical example of a PERT analysis, we have 4 different events and 4 different arrows or lines, and each lines represents numbers of weeks that needs to be completed or complied uh, for the event to be completed. So for event 1 to event 2, we need 4 weeks. For event 1 to event 3, we need 12 weeks. For event 2 to event 4, 10 weeks. And then event 3 to event 4 is 8 weeks. So event 4 will not start unless event 1 to event 2 is finished and event 1 to event 3 are also finished. Hindi siya pwedeng mag-start unless tapos na yung tatlo. Okay, so the placement of the circle has a significance on the analysis of the events using the PERT system. Okay, now, we need to learn also how to compute for the average time or the expected time in each activity. Normally, we are given 3 kinds of time: optimistic time, most likely time or the average time, and the longest time, which is the pessimistic time. So yung optimistic, you wanted to finish early and therefore the shortest time. The pessimistic time is the longest time. You don't want to finish early. You wanted to have some rest, kaya the longest time yun. And then the average time. Okay. So the formula for the expected time is to add optimistic time plus 4 times most likely time plus pessimistic time over 6. So this is the formula to compute for the expected time. And then in PERT system or PERT networks, we need to identify the critical path and how to determine which activity has a slack time. So critical path is the longest path in the network in order to complete the project. So going back to our previous example, comparing path 1, 2, and 4, it needs 14 weeks. Comparing it to 1, 3, 4 path, that is 20 weeks. So in short, the critical path here is 1, 3, and 4. That's the longest path to finish the project. So if that is the case, even if event 1 to 2 is finished, it can and event 2 to 4 is still ongoing, and even if they finish their activity, event 4 will not be finished yet because event 1 to 3 and 4 requires a total of 20 weeks. So there is a slack period for both 1 to 2 and 2 to 4 of 6 weeks. Okay? So path 1, 3, 4 is the longest path. So therefore, that is the critical path. Any delay on this path will add additional time for the entire project. Unlike in path 1, 2, and 4, they can relax for 6 weeks while waiting for the path 1, 3, 4 to finish their 20-week period. So this is the critical path. For the time, slack means the length of time by which a particular activity can slip without having any delaying effect the ev- on the event, on the end of the event. So in path 1 to 4, since they only have 14 weeks to finish all their tasks, and path 1, 3, 4, which is the critical path, needs 20 weeks. Therefore, there is a slack time for path 1 to 4 of 6 weeks. That is the amount of time which can be slipped without having a delay on the entire project. Okay, another way of computing the slack time is to deduct the earliest start with the latest, not later, late start, or early finish minus late finish. What they mean by early start and early finish, late finish. Okay. Uh, Whenever we do a project, we always assign an estimated time period for us to finish the project. And each event is allotted with a specific time period also, which will contribute to the completion of the project. So for this particular example, we have a total of 20 weeks to finish all the event. 14 weeks for path 1 to 4 and 20 weeks for the path 1, 3, 4. Okay? So for activity 1 to 2, it requires 4 weeks. 1 to 3, it requires 12 weeks. 2 to 4, 10 weeks. And 3 to 4 is 8 weeks. Now, the earliest time to start the activity from 1 to 2 is 0 weeks, right? So start from 0, the earliest start, and then after 4 weeks, events 1 to 2 will finish. So the earliest finish for events 1 to 2 is 4 weeks. So 0 start, early start, and uh, early finish is 4. So for events 1 to 3, the earliest start is again 0, and the early finish is 12 because it requires 12 weeks before you finish event 3. So the early start is 0, the early finish is 12. And then for events 2 to 4, the earliest start is after 4 weeks. So 4. They cannot start on the third week because events 1 to 2 is not yet finished. So the earliest start is after 4 weeks. And therefore, the earliest finish is 14 weeks after 10 weeks. Earliest start of event 3 to 4 is 12 weeks plus the 8-week period. The earliest is finish is 20 weeks. So as you can see, whenever we compute for the early start and early finish, we start from the beginning. Comparing it to the latest start and latest finish, we will start from the end. So if uh, the required period to finish all the event is 20 weeks, we start from 20. So therefore, the latest finish of events 2 to 2 to 4 is 20. Latest finish is 20. That's the late finish. Since it requires 10 weeks, the latest start of 2 to 4 is 10 weeks. And therefore, if that is the latest start, that will become the latest finish of events 1 to 2, 10. Because uh, the trigger point for events 2 to 4 is after you finish events 1 to 2. So if you started at 10, probably the events 1 to 4 finished at 10 also. So the latest finish of events 1 to 2 is 10 minus 4. So the latest start of 1 to 2 is 6. They can uh, delay or maybe wait after 6 weeks to start, and that will be their latest start, 6 weeks. And after 6 weeks, they will start uh, doing their task. After 10 weeks, event 2 to 4 will start also and finish at 20 weeks. Okay, let's compute for the latest finish on path 1, 3, and 4. So latest finish of 3 to 4 is 20 minus 8. The latest start is 12. That 12 is also the latest finish of 1 to 3 path. Minus 12 is 0. Okay, we can now compute for the slack. Either we use ES minus LS or EF minus LF. So let's start from ES minus LS. 0 minus 6 is 6. Or 4 and 10 is 6. 4 and 10 is 6. 14 and 20 is also 6. 0 and 0 is 0. 12 and 12 is 0. 12 and 12 is 0. 20 and 20 0. So those with slack time is path 1 to 2 and 2 to 4, which is true enough when we analyze using the PERT, which and the critical path 1 to 2 and 2 to 4. 6 weeks in total. Cumulative slack time for 1 to 2 and 2 to 4 is 6. Next is crashing. Sometimes uh, the one who asks for the project may request for a faster completion of the project, but of course at the lowest cost. This refers to the effort to design to complete the project ahead of the schedule. And expect whenever you crash, the variable cost will surely increase. However, crashing means finding the minimum cost of completing the project in the minimum time. Okay. In crashing procedure, we need to compute for the incremental crash cost. And that is crash cost minus the normal cost divided by the numbers of days saved. Meaning, this is the additional cost that we will incur whenever we squeeze the time to finish a particular activity. That is crash cost minus normal cost divided by numbers of days saved. Okay, let's go to the illustration for the crash cost. Assuming that a special project of ABC Manufacturing Company with a total normal cost of 316,000. The PERT time inputs are shown in this network. So we have here 7 events. With their corresponding time period for each event. For 0 to 1, we have 16 days. 1 to 2 is 11 days. 2 to 3 is 7 days. 1 to 4 is 22 days. 26 days, 16 days, 12 days, 9 days, 14 days. And this one has 0 days, meaning that's the reason why it was supposed to be a broken line because it doesn't actually entails any time at all. Kaya broken line siya, 0 time. Okay. Let's try to look for the critical path. Again, what's the critical path? The longest time, the path with the longest time. So 0, 1, 2, 3, and 7 is 48 days. 0, 1, 2, 3, 4, 6, 7 is 55 days. 0, 1, 4, 6, 7 is 59 days. 0, 1, 5, 6, 7 is 67 days. So therefore, the critical path is 0, 1, 5, 6, 7. Okay. Now, the management wants to determine whether the project's completion time can be shortened at the least possible incremental cost. Originally, we can finish the entire project for 67 days. We wanted to find out, can we crush it? Can we reduce or shorten the period? Now, if you do crushing, you have to assign an alternative numbers of days to finish the activity, which should be lower than the original estimated time. So I highlighted the estimated shortened time for each of the activity. There are activities that we cannot shorten, and therefore they do not have the highlighted amount or figure. So only events 1 to 2 can be shortened from 11 to 9. Events 2 to 4 can be shortened from 7 to 4. Events 3 to 5 from 14 to 5 days. Events 1 to 4 from 22 to 18 days. Events 1 to 5 is 26 to 10 days. And 16 to 8 days for events 5 to 6. And then you need to also assign the crash cost, the incremental crash cost. So for this particular example, we will not be using the formula. Instead, we are now given the exact amount of incremental cost. And that is 2.4 for events 1 to 2, 2.8 for events 2 to 3, 1.8 for 3 to 7, 2.6 for 1 to 4, 2,000 for 1 to 5, and 2.5 for 1 to 6. Now, the first step in crushing is to determine the critical path. And we already identified that, and that is path 0, 1, 5, 6, and 7. After determining the critical path, you need to choose the lowest incremental cost. So between 2000 and 2005, the lowest incremental cost is 2000. Now, you might be able to think na computing it by total, it seems like crashing 5 to 6 is uh, less expensive or less costly than crashing 1 to 5 for 2000 each, because that's 16 difference in time times 2000, comparing it to 8 times 25. However, we will not do that simply because our objective is to shorten the entire period. And therefore, we will choose the highest numbers of days that we can save from 26 to 10. This one is 16 days. And the lowest cost, and that is 2,000. Okay? So we will crush 1 to 5. If we will do that, from 26, it will become 10. It will be shortened to 10. So therefore, the entire amount of time to finish the path 0, 1, 5, 6, and 7 will become 51. That's, oh, I wasn't able to change it. Hold on, let me change it. Okay, so 16 plus 10, the crush time, plus 16 plus 9. And that is equals to 51. Okay, so doing that, uh, the original cost of 316,000 will increase because of the additional cost we will incur for saving the days, the numbers of days, and that is 2,000 times 16 days. You will add that to the original cost of 316,000. We will now have a total cost of 348,000. So we will be able to finish it, uh, the activity 1 to 5 in 10 period, but we will be uh, charging 300 or incurring 348,000. Now doing that, we can recognize now that we have a new longest path, and that is the path y, from 0 to 1, 1 to 4, 4 to 6, and 6 to 7. It has now the longest days to finish, and that is 59 days. Okay, so with the shift of the critical path, we can still uh, shorten the period of the entire project. But this time we will look at uh, for an activity to be crushed within the critical path. Okay, so I have changed already the uh, time period for the events 1 to 5 to 10, as we assume that it has been crushed already. Now, the new critical path is 0, 1, 1 to 4, 4 to 6, and 6 to 7. So within that path, we will look for an event that we can crush, and it seems like we only have one choice, and that is 1 to 4. From 22 days, we can crush it to 18 days with a 2,600 pesos crush cost for every day of crushing. Okay? So that will be our lowest cost kasi wala namang choice. So, crushing it from 22 to 18, we will have a new numbers of days, which is 55. That's 16 plus 18 plus 12 plus 9 equals 55. Doing that, we will now have a new crash cost or new project cost of 358,400. 348 from the original uh, crashing of 1 to 5 activity plus 2,600 at 4 days equals 358,400. Okay? Doing that, we can now recognize also that there is another critical path with the same amount of uh, days to finish, and that is X, path X, 55 days. Now, uh, although there are activities that can be crushed within that path, crushing any of these events will reduce path X or path 0, 1, 1 to 2, 2 to 3, 4, 3 to 4, 4 to 6, and 6 to 7, but will not reduce path 0, 1, 1 to 4, 4 to 6, and 6 to 7. So therefore, any crushing that we will do in path X will not make or will not change the pathwise numbers of days to 55. Hence, we have reached the final crushing period or the final crushing process for the entire period of finishing the entire project. And that is up to 55 days, which is originally 67 days. Next is the concept of standard variation and normal distribution. Remember the formula for this estimated time that we need to divide the optimistic and the pessimistic and the mostly likely time by an average of 6. Now, this estimated time, let me open a specific example. Say the events 1 to 5, 1 to 2. Events 1 to 2, for example, 11 days. And we were able to arrive at 11 days by assuming a given optimistic time of 7, a most likely time of 10, and a pessimistic time of 19. Uh, Following the formula will arrive at 11 days. Now, uh, in the actual scenario, 11 days is 11 days is still an estimate. That's why we call it estimated time. And since this is an estimate, there will be some variability of completing the event or the project within that period of 11 days. And therefore, we have to look for the standard variability or the standard deviation from 11 days. And that is by using this formula. That is pessimistic time minus the optimistic time divided by 6. And we will arrive at standard deviation of 2 days. So what does it mean by standard deviation? This means that uh, normally there will be a deviations of 2 days. That is a plus and minus 2 days from the estimated time. So in short, we may be able to finish it within 9 and 13 days with one standard deviation. Okay? One standard deviation is equivalent to 2 days. So plus and minus one standard deviation from the mean or from the 11 days is equals to 9 and 13 days. So within 9 to 13 days, we can finish the project 68% chance. And how did we able to determine that 68%? Well, by the use of the normal distribution. A normal distribution is a graphical presentation of uh, the probability of attaining the average numbers of days we need to finish the event. So in our case, that's 11 days. Okay, so we may be able to finish it earlier or we may be able to finish it later. So with one standard deviation, which is equivalent to 2 days, uh, and therefore that is between 9 and 13 days, according to our uh, table for standard deviation, there is a 68.2% of finishing the project earlier or later by 13 days, 9 days to 13 days. We have 68.2%. And how did we get 68.2%? You have a copy of the table on page 377 and then look for the z value of 1.0. You will find an area of 0.341. That is one standard deviation from the mean. So since we have positive 1 here and negative 1 here, that is equivalent to 3.341 on the right side and 0.341 on the left side for a total of 68.2%. Now, if we wanted to know the probability of finishing it, uh, the earliest time or the longest time, we may add additional standard deviation of another 2 days, and that is 7 to 15 days. That we get 7 since one standard deviation is equivalent to 2 days as computed earlier. 2 standard deviations is equivalent to 4 days. So between 7 to 11 days, that's 4 days, and 11 to 15 days, that's 4 days also. So what's the probability of finishing between 7 to 15 days? That's 95.4. How did we get 95.4? You look at the table and you will see the z value of 2 have an equivalent area of 0.477. And that is equivalent to 95.4. Okay, so what does this uh, trying to tell us? This means that 68, we only have 68% chance of finishing the project within the estimated time, and the variability is between 9 to 13 days. If you wanted a higher confidence level, well, you have to adjust from 7 to 15 days to finish it within the estimated time. And that gives you 95.4 confidence level. Okay, aside from the variation on a per event basis, we can also compute for the variation along the path. Remember what we have computed earlier is the variation for the 11 days or for the specific event. For the path, we can also compute by using this formula. Square root of the sum of the deviation squared. So using the uh, illustration earlier, we simply get the estimated time using the formula. So we will have 67 days. Okay, and then get the standard deviation for each event, 3.33. And then you square each standard deviation, and then you sum it up, equals 58.78. And then you get the square root of 58.78, that is equivalent to 7.67 days. What does it mean? Since this will become the standard deviation of the path, completing the project at 67 days may vary depending on our confidence level. If our confidence level is 68.2, which is equivalent to one standard deviation, the minimum days to finish the project is 59.33. That is 67 minus the one standard deviation. And the maximum period is 74.67 days. That is 67 plus 1 standard deviation of 7.67. Whenever we increase our confidence level, the numbers of days, the maximum numbers of days will also increase, and the minimum days will also be decreased to 43.99%. But again, we cannot conclude that we have 99.9% assurance that he will finish for the project for 43.99 days. It means our confidence level of 99.9% is within the minimum of 43.99 to 90.01. Okay? Next is a Gantt chart. A Gantt chart is a bar chart with time shown on horizontal axis and the duration of the task represented as a bar running from the starting date to the ending date. Now, we have here the example of a Gantt chart showing a project with 4 different tasks. Task A, B, C, and D. And it was scheduled to be finished on the last quarter of the year, and that is October to December. The solid line on a horizontal basis or horizontally written line represents the work scheduled by period within the department. So for task A, it was scheduled in the first week of October, second week of October, second week of November, and last week of December. Well, the vertical, short vertical broken lines, it represents the it represents the work unfinished or carried over from the previous period. So for task B, we have here a short vertical lines. Uh, this means that task B were uh, delayed and were unfinished and was carried forward to the next month or next period. It was supposed to be done within the first to the second week of October, and then third to fourth week of October, and then maybe third week of November. However, there's a delay, so therefore there's a broken solid vertical lines here. And then the uh, short vertical lines represents the total numbers of months that numbers of weeks that a particular task was assigned. So for this one, for task A, he was assigned for 4 weeks, although different period. So the shaded part is 4 weeks. For task B, it was originally for maybe 3, maybe 4 weeks also. 1.5 here, 1.5 here, that's 3, plus 1 week, that's 4. However, since there is a delay, as you can see, the shaded part is beyond 4 weeks. Okay, task C is assigned for 1, 2, 3, 4, 5, 6 weeks. Therefore, the shaded part is 6 weeks. Task D is given 1, 2, half of this, that's 3, 4, half of this, 5, and then whole of this, that's 6 weeks. So a total of 6 weeks. So this broken vertical line represents a delay of the project. And therefore, there's an increase of uh, required numbers of days to finish it. And then, finally, is the inventory modeling. The normal problems in inventory is to determine the uh, optimum numbers of units to be ordered so that we can uh, arrive at the least cost of ordering and the least cost of carrying our inventory. And we can do that by using the EOQ formula. That is the square root of 2 times the annual usage in units times the cost per order over the carrying cost per unit. The same concept may be applied to economic lot size by changing the cost per order by the setup cost. And then with that formula, we can also compute for the total annual ordering cost and the total carrying cost, which is expected to be equal at EOQ level. The total ordering cost and the total carrying cost is the same at EOQ level. And then part of the uh, analysis in the inventory modeling is the computation of the safety stock. which is the maximum usage minus the average usage times the lead time. This is the numbers of units needed while waiting for the arrival of your order. That is why they call it safety stock. The reorder point or ROP is the numbers of units uh, that you need to maintain and the one that will trigger an order before you run out of stocks. And the formula for this is average lead time plus the safety stock. The average lead time is lead time plus times the average usage per unit of time. So let's go to the illustration. Otis Company buys ping pong balls at 25 per dozen from its wholesaler. Otis will sell 35,000 dozen baseball. Maybe that's ping pong balls, but naging baseball. Evenly throughout the year. Otis desire a 12% return on investment or the cost of capital on its inventory investment. In addition, rent, insurance, taxes, etc. for each dozen ping pong balls in inventory is 3 pesos and 50 cents. The ordering cost is 10 pesos. Lead time is constant at 2 weeks and there are 50 working weeks in a year. The maximum expected requirement per week is 850 dozen. So let's compute first for the annual, and that is 850 at 50 weeks, and that is equivalent to 35,000. Okay, let's compute for the EOQ. That's square root of 2 times the annual usage of 35,000 times 10 divided by 350 equals 447 dozens. So this EOQ units will be the basis of the numbers of units to be ordered for every order. Ano daw? The numbers of units to be ordered for every order. For the total annual ordering cost, that's 35,000 over 447, you will get the number of times you will order in a year. Multiply by the ordering cost of 10, that's 782.99. For the carrying cost, that's the average ordering units for 47 over 2 times the carrying cost per unit, that's 350, equals 782.25. So we have a little difference on the centavo here, probably because of the rounding of numbers. But as you can see, ordering cost and carrying cost are equal in the EOQ level. Safety stock is 850 minus 700. That's the weekly requirement times 2 weeks. So you need to maintain 300 dozen upon ordering so that we will not lose any sales. The reorder point is 350 over 50 times 2 weeks plus the safety stocks, and therefore 1,700. The average lead time is 1,400 dozen. So the only difference between the average lead time is your safety stock, which is 300 dozen. So when you reach 1,700 dozen, that's the time you should order 447 units of ping pong balls. Okay, that's it for the chapter 12. Thank you very much for listening.